Hello Horizon students, this is Miss G, and today you will do your diaper polymers experiment. But first, let's review Unit 2. So we started Unit 2 with our silly putty experiment, and we learned about the three states of matter, and those are solid, liquid, and gas. So make sure you know the difference between those three states of matter. For some classes, we also learned the difference between a solution and a mixture, and the difference between a physical change and a chemical change. So if that was your class, make sure you know those terms as well. For our quicksand goo experiment, we learned about viscosity, which is the measure of thickness or resistance to flow in a fluid. So be sure to be familiar with all of these terms, and if you have any questions, please write them down so that you can ask me once I return. Today you will learn about osmosis and diffusion. Diffusion is the movement of particles from an area of high concentration to an area of low concentration. So for example, in the picture to the left, someone is dropping a drop of purple dye into a beaker of water. Initially, that drop of dye is very concentrated in one small spot at the top of the water. Over time, however, that drop of dye spreads out so that it's evenly distributed across that beaker of water. That is an example of diffusion because the dye is moving from an area where it is very concentrated in one small spot to all over the fluid, which makes the concentration much lower. Osmosis is the diffusion or the movement of water. So in the picture to our right, we have a carrot on the left that is the normal size of a typical carrot. The carrot on the right, however, has been sitting in water for a considerable amount of time. So the water has rushed into that carrot and made it much larger than its normal size. This can also be seen if you place a gummy bear in water for a considerable amount of time. That gummy bear will expand because of all the water that rushes into it. That is an example of osmosis, or the movement of water. Now we will move into our diaper polymers experiment. So I'm sure all of you have seen a baby diaper at some point in your life and you know what they are used for. It is very important for baby diapers to be absorbent because we don't want any issues with diapers leaking. So manufacturers of diapers put a chemical in them called sodium polyacrylate, and these are crystal-like structures that are found in the fluffy layer of baby diapers. Sodium polyacrylate is super absorbent. It can hold up to 100 drops of water, and that's very important for baby diapers to be very absorbent. So today you're going to test the properties of sodium polyacrylate, and these are our materials: absorbent diapers, Ziploc bags, small plastic cups, food coloring, a spoon or a plastic tablespoon measure, scissors, and medical masks. And the reason why you need to wear the medical mask is because when the crystals are outside of the diaper, they can sometimes irritate the nose. So in order to prevent this, we want to make sure that you wear the mask so that you're not coming into direct contact with these crystals. So before you do the experiment, I want you to take some time to think about the following questions. How will these materials be used? What do you hypothesize will happen when we combine these materials? The experiment today has a lot of very important steps, so I did not want you to just read them. So I'm going to show you a video that I recorded for you that shows how to perform this experiment correctly. start to notice that the crystals will gradually absorb all the water that's in this mixture. So you can play around with this, you can take it out, you can touch it, just don't hit it. And these crystals can hold up to 100 drops of water, so they are super absorbent. So you can play around with this for, I'd say, about 5 to 10 minutes before you move on to the next part of the experiment. So after you finish playing with the crystals, somebody will come around with salt. You might be wondering what this salt is going to do to the crystals. Well, the salt will draw the water out of the crystals. So let's see what happens with the salt. And put a large sizing of salt on your crystals. And if you want to save some of this to take home, make sure you take a portion out of the cup and put it in a Ziploc bag before you put the salt in. So I'm going to mix this salt in and see what happens. Okay, so as you can see, after a few minutes of mixing and adding some salt in, our jelly-like substance is no longer very jelly. It's more like a liquid because the salt drew the water back out of the crystals. So now it's back to its liquid state. So this is an example, like I mentioned in the lesson, of osmosis. So in the lesson I mentioned this diffusion and osmosis. Diffusion is the movement of anything else but water. Osmosis, on the other hand, is the movement of water into or out of a substance. So this is an example of osmosis. I hope that you have fun doing this experiment, and I can't wait to tell about it when I get back. So after you finish the experiment, if time permits, please answer the following questions and have a discussion on the following questions. What happened when you put water on the crystals or the sodium polyacrylate? What happened when we added the salt? How does this work in baby diapers? If you have any additional questions, please feel free to write those down so that I may answer them when I return. I certainly hope that this experiment was a success for you all and that you enjoyed doing the experiment, and I appreciate you for listening. Thank you very much, and I will see you when I come back. Have a great week.